Most metals oxidize rather easily in air. There are a few exceptions, for example gold, which is one reason why gold was one of the first metals historically that was discovered, because it stood out rather starkly from its environment. If we look at the reduction table values for gold 3 being reduced to neutral gold and oxygen being reduced essentially to water in the presence of acid, if we look at these reduction potential values, we notice that for the reduction of gold 3 it's positive 1.50, and for the reduction of O2 positive 1.23 volts. We mentioned previously that the positive nature of this reduction potential indicates that the substance would rather exist like its state of matter that's shown on the product side here, and that the magnitude suggests how strongly it wants to do that. You can see from these two values that while oxygen is quite happy to be reduced to water, gold 3 is more willing or more happy to be reduced to neutral gold. So sometimes you can tell by looking at the values from the reduction table whether a metal is more likely to oxidize in air or not. Corrosion is the spontaneous redox reaction in which metals react with something in the environment to form unwanted compounds. For example, silver sulfide, known more commonly as silver tarnish. The silver is reacting with sulfur in the environment, giving this tarnish to things that are made of silver or coated with silver. Galvanic corrosion can occur when two different metals are in contact. We learned previously that a galvanic cell is one in which we just set up the system and it goes on its own. That's pretty much what has happened here in each of these pictures. We've set something up, there are two different metals that are in contact, and especially if those metals have some access to water and possibly electrolyte, corrosion is going to occur much more rapidly. Galvanic corrosion, two different metals in contact with each other. Within a given metal, corrosion is initiated most readily at points of strain. For example, at bent regions, if the metal is bent, or at welds. You can see a picture here. This is some kind of a storage tank consisting of steel plates that have been welded together, and you can see that the corrosion is starting here on the weld. Here's another research project that someone was working on, and we have a bent nail in an agar solution containing potassium ferrocyanide, sodium chloride, and phenolphthalein. The potassium ferrocyanide turns blue in the presence of the iron 2+ ion, that is where iron is oxidized to iron 2+, and phenolphthalein turns pink in the presence of the hydroxide ion, that is where O2 is reduced. So you can see in this picture that there's a nail that's been bent. It's been suspended in this agar gel-like solution that has been infused with a few things, and that point of bending gives a nice location for corrosion to begin, and once it begins it just wants to keep right on going.